this video, we're going to investigate the product rule of exponents. The idea behind the product rule of exponents is if we see a cubed, what this means is a times a times a. When we see a squared, what this means is a times a. What we have are 3a's multiplied and 2a's multiplied. So if we want to abbreviate it all with a single base of a, there are a total of 5a's being multiplied together, or a to the 5th. We might notice an easier way to do this problem would be to take the exponents 3 and 2 and add them together to give us the a to the 5th. This is the product rule of exponents, by adding the exponents on the common base. So for example, on this problem on the bottom left, where we have 3 squared times 3 to the 6th times 3, we'll first need to remember that if there's no exponent written, we assume there is a 1. We've got a total of 2 3's multiplied, 6 more 3's multiplied, and 1 more 3 multiplied. To find out how many 3's there are total, we simply have to add the exponents. 2 plus 6 plus 1 is 9. This is equivalent of 3 to the 9th power. On the right side, we have 2x cubed y to the 5th z times 5x y squared z cubed. We can multiply numbers like always. This property has not changed. 2 times 5 is 10. And then when we look at the variables, we can see how many of each variable is multiplied together. We have x cubed times x to the 1st. There are a total of 4, or 3 plus 1, x's multiplied together. Similarly, on the y's, we have y to the 5th and a y squared. Total multiplied together, 5 plus 2, are 7 y's. So we have y to the 7th. Also, on the z's, we've got z to the 1st times z cubed. The total number of z's multiplied there are 4. 3 plus 1 is 4. And so when we multiply 2x cubed, y to the 5th, z to the 1st, by 5x to the 1st, y squared z cubed, we end up with 10, x to the 4th, y to the 7th, z to the 4th. Again, the product rule of exponents says that we can combine the same base together, if it's multiplied, by adding the exponents to find the total number of that base that's multiplied together.